Hey everybody, Dr. A here, and in this video we're going to be exploring another example of how to use deflection formulas. So let's go ahead and get started. In the given information, we're being asked to compute the maximum deflection, and we're being told that the flexural rigidity, or the product of E and I, is constant. So here we have a cantilever beam. It's fixed at the left support, and it's free at the right end, 15 feet long, and it's supporting a uniformly distributed load of 0.2 kips per foot, or KLF. And then also at the free end, at the right end, we've got a moment being applied, an applied couple moment of 1 kip foot, okay? So how do we reconcile this? Well, again, we're going to use superposition, all right? So by superposition, we can rewrite this as the effect of each of these loading scenarios occurring, all right? And so here we've got, the 0.2 KLF, and we have this deflection here. We'll call that delta 1, all right? And, this beam is 15 feet long. And then we're going to add to that the effect from that applied couple moment. And again, that beam here is also 15 feet long, and we have 1 kip foot being applied here. Now notice the direction of that couple moment, okay? This is going to cause it to bend concave up, all right? And, this deflection right here, we could call this delta 2, all right? Now, you got to be careful because here the signs are going to be different, right? Delta 1 is going down, delta 2 is going up. So we're going to say that delta maximum is going to be negative delta 1 plus delta 2, okay? And so you got to be careful. Again, our pre-derived formulas tend to have the signs, the SIGNs, already built inside of them. So if you're looking at a table of formulas that has a negative sign built in for a downward deflection, don't double count that negative, okay? It's got the negative in the formulas often refers to a downward deformation or a downward deflection. So be very careful depending on what table you might be looking at, okay? What I'm going to do is I'm going to pull out some equations here, and for the uniform load case, we're going to have negative WL to the fourth over 8EI, okay? Now again, be very careful here. This negative in front of WL to the fourth over 8EI, that's the same as this negative, okay? Don't double count them. Don't say a negative times a negative is a positive. This negative and this negative are the same negative, all right? And then we're going to add to that delta 2, which is going to be given as the formula ML squared over 2EI, okay? And notice no negative sign there because this is causing delta 2 to displace upwards, all right? So let's go ahead and substitute some values in now. We have delta max equals, we're going to say negative 0.2 KLF times 15 feet to the fourth power over 8 EI. And then we're going to add to that plus 1 kip foot times 15 feet squared over 2 EI, all right? And we're going to punch this through and see what we get. So for the first term, I've got negative 0.2, of course, times 15 raised to the fourth power divided by 8. So for that first term, I'm getting a negative 1266 over EI, and the coefficient of 1266 is carrying units of kip times feet cubed, okay? And in fact, let me just write this beneath it. How about that? Be a little bit more organized instead of trying to cram it all at the edge of the page. So negative 1266 kip feet cubed over EI. And then I'm going to add to that, 1 times 15 squared over 2. So we're going to add to that 12.5 kip feet cubed over EI. All right, so a couple things to note here. Did I need to convert any units in this problem? No, not really. I mean, I was not given actual values for E and I, so we just keep the E and the I lumped together in the denominator. We don't actually substitute values in for E and I since we don't have any. All right, and also note that the numerator values carry their own units of force times length cubed. All right. And so we can add these together, and what happens when we combine these together? We get a value of negative 1153 kip feet cubed over EI. And what does that negative indicate to us? Well, that indicates that we have a downward deflection. So ultimately, this deflects downward, right? 1153 kip feet cubed in the numerator over EI. All right. So again, that numerator has these units, and this is going to be a downwards deflection. And that's pretty obvious when you look at these numerical values. I mean, that first term that is due to the uniform load is much larger than the magnitude of the second term due to this applied couple moment. So even though that applied couple moment is lifting this beam up a little bit by its free end, that uniform load is pushing it down more than the applied couple moment is lifting it up. So you have a net deflection downwards. Okay, so that concludes this example. If you found this helpful, please hit like and subscribe and be on the lookout for other content like this. Thanks for watching.